Okay, here are the section 5.1 notes, quadratic functions, page 4. Flip this sideways so we got a better picture. So, applications. We used to call them word problems and everybody would freak out. But you guys, this is how we truly do use math in the real world. We got a backyard farmer who wants to enclose a rectangular space for a new garden within her fenced backyard. She's purchased 80 feet of wire fencing to enclose 3 sides, and she will use a section of the backyard fence as the 4th side. So here's our existing fence. And right now you're thinking, well, she could just spread it out and see what she's got to work with. But the goal here is to make the enclosed area as large as possible, and you can't always eyeball that. Let's see. We want a formula for the area enclosed by the fence if the sides of fencing perpendicular to the existing fence have length L. So we're going to go this way. This one's going to have length L. We're going to go this way. We can call that W. And we're going to go this way. We can call that L. Okay. What dimension should she make her garden to maximize the enclosed area? Well, let's figure that out. So the first thing we are going to do is write down everything we know. We want to maximize area. My area of a rectangle is length times width. Okay. I also know that we've got 80 feet of fence. So this L plus W plus L has to equal 80. Now I have 2 equations that have 2 different variables in them, which is a little unsettling. But I'm going to go ahead and take this second one, combine my L's. So that's the same as 2L plus W equals 80. And then I'm going to go ahead and solve for W. I'm going to get W by itself by subtracting those 2 L's off. Cool. Why would I do that? I would do that because now I can take this W and replace it up here in the equation for my area. So now my area looks like this. L times 80 minus 2L. I have an equation written only in L. Fair enough. I could multiply that L through and then rewrite this in descending order and not get rattled by the fact that I'm using L instead of X. I have a negative leading coefficient. Which means that my parabola should open down. That's a good thing if I want a maximum quantity, maximum area. So that makes sense. I'm going to go ahead and subtract out negative 2L and see if I can make this a little more useful. So this equals 0, and we'll talk about why we're setting it equal to 0 in a minute, when L equals 0 or L equals 40. Which means if I were graphing this as a parabola with my super straight axes there, I have a parabola that opens down and crosses at 0 and 40. That tells me that my vertex is halfway between those two. Vertex at my length equals 20. Why is that a big deal? Well, notice here in the problem, they don't ask us to find the maximum area, just what the dimensions have to be to give us that. So I know that The maximum area is found when my length is 20. I have two lengths of 20 in my 80 feet. So that means my width is 40. Application number 2. We have a ball thrown upward from the top of a 96-foot high building at 80 feet per second. Here is the ball's height. Here's that initial velocity. Okay. We want to know when the ball reaches the maximum height. What is the maximum height and when the ball hits the ground? So I've got my height function. And because I'd rather work with smaller numbers, I am going to see if I can factor that negative 16 out. And I get this function. Negative 16 equals t squared minus 5t minus 6, which I can factor further. Yeah, let's do this. Because what I did was jump ahead and solve for when this is 0, which actually means when this is hitting the ground. Okay. When my height is 0, this is hitting the ground. So I've started by answering 3. It doesn't make any sense to say it hit the ground 1 second ago. So 3, the ball hits the ground. At t equals 6 seconds. Sorry, I was thinking it but not saying it out loud. So now I'm going to go back and answer 1. I need to find the vertex, which is going to be halfway between -1 and -6. Sorry, -1 and +6. And two and a half seconds. The ball reaches its, sorry, no apostrophe, maximum height at 2.5 seconds. And then we want to find the maximum height. Now, because it is easier for me to multiply fractions, I'm going to go ahead and use 5/2, square that, and notice I'm putting this into the factored form. All of those forms should work. But these numbers are smaller, which is going to make my life easier. I get -16. When I square 5/2, I get 25/4. When I multiply 5 times 5/2, I get 25/2. Can you do this with the decimal? Sure. I just don't happen to have a calculator handy. So I'm going to rewrite all of these so we have a common denominator. And I'm going to get negative 16. I'm going to subtract these in a different order. 25 minus 24 gives me 1/4, positive 1/4. Minus 50 over 4 gives me negative 49 over 4. Two negatives are going to make a positive for me, which makes sense. My maximum height should be positive. I'm going to cancel this 4 with one of the 4's here. So I got 4 times 49, which is 196 feet. This hits a maximum of 196 feet. And that's it.